and we find the value of the optimal x1, x2, or x3, no matter how many variables we have. Now, so the first thing is to prepare it for the two-phase method. By preparing, I mean that we have like equal to and greater than or equal to. Okay, here we have two constraints, and one is equal to, and one is greater than or equal to. So we will have to add an artificial variable r1 over here, and we have to add artificial variable r2 over here and subtract, as it is greater than or equal to, so we have to subtract a surplus variable. Okay, now doing this part of the problem, now we get the and here we have 2x1 minus 5x2 plus x3. Here we will subtract the surplus variable and will add the second uh, artificial variable. Okay, now according to this, we will now change the what we call it, the maximization the function that we had. Now we will have a minimization function. Okay, and the minimization function in maximization we'd had maximum z. In minimization we will have the minimum r. Okay, is equal to r1 plus r2 and subject to m constraints that we just made. Okay, now just like we do the simplex, we will do minimize r is equal to r1 implies that r minus r2 look, we have these artificial variables. Okay, and we want to eliminate those. Yes, and these will actually balance the constraints that we have, like here. The balance is brought by R1 and R2. So when we do the maximization, we actually eliminate the artificial variables. It's just like, you add something, you add a catalyst, and then you remove that after the process is done, and you get a solution. So here we add those. We just removed it. R minus R1 minus R2 is equal to 0. We will bring the value of R is equal to 0 in the right hand side. In maximization, we bring the value of Z in the Z column, Z row to the maximum. Here we will bring the R value in the R row to the minimum 0. That is the difference. Look, this is a maximization problem. So we need, no, we don't have to do that. Then it is already in the minimization form. We just have to follow same instructions like this. This is just an extra step that you want to do in two phase. The first phase is that you want the artificial variables to be 0. Similarly, in the big M method, you want the artificial variables, the m's, to be 0. We did it previously, no? Yes, yes, but that yes, but that is the algorithm that we are, following. I'm not doing it like by myself, like okay, if you do this, if you do that. No, the algorithm says that if we have such problem, even if it is minimization, okay, we add the artificial variables, and then we solve it first for the artificial variables that we added. We made that zero, and then we solve it for the z. The two phase method. The first phase is solved for the uh, yeah, it is just for the two phase. Yes, yes. For R, when we add artificial variable, you must make it minimum, make it zero. That is how it is done. So if it is minimization, so it is already a prepared case. You just go for minimization of R1 and R2. Even and if it is maximization, you just convert it to the the standard form of it. Then you convert it to the R form of it, and you keep the R as minimum R. You don't go for maximization of R in both cases. Even if it is minimization, we have to do this minimize R. Yes. Yes, in both of these cases, when we calculate it for R, we need to go for minimize R. Do not go for the opposite, like maximize R in the minimization end. Yes, for R, whenever R comes, whether it is in the big M method, whether it is in the two-phase method, whenever there is an artificial variable, you need to have it zero. You need to want it to make it zero. That is how you solve it. We will go for eliminating it. Okay. So the first phase is this one. This is the first phase. In the first phase, we solve it for small r. Like we the basic problem is for z, but here in the first phase we solve it for r, small r. Okay. Now, just like we convert the z into equated to zero, similarly we do it for r also. Just like I did, r minus r1 minus r2 is equal to zero. Okay. Now, subject to constraint, the constraint will remain the same. It is also subject to constraint, and the constraints are x1 plus x2 plus x3 plus r1 is equal to 7. And the second is 2x1 minus 5x2 plus x3 minus s1 plus r2 is equal to 10. So these two are the constraints. Now I will make a table, a standard table of it, and then I will show you what to do next. Okay, because it has an extra operation, just like we do it in the big M method. So it also has an extra operation. Now I will say basic variable. I will solve it for R. Here we used to write Z. You understand? But here we will write R because we have the minimization function in R. So we will write R over here. Now the other basic variables are R1 and R2. As S1 is the surplus variable, we do not consider it just like we do it for any big M method or the simplex method. Okay. You understand? Okay. So now here we will write as it in the x form. Okay. X2 and x3. These are the variables. And here I will write R1, R2, and S1. And here I will write the right hand side our solution. Okay. And then the ratio. But here we do not need to do the ratios because we will need an extra operation to do. And then we will go for the ratios and all that, entering and leaving variable. So now for R, this is equal to 0, this is equal to 0, this is equal to 0. Just like in Z, we used to have R1, S1, S2, and S3 is equal to 0. So in R, X1 will be 0, X2 will be 0, and X3 will be 0. Just opposite of that. You understand? Now R over here is -1, and here is it is also -1. And S1 is also 0, and the right hand side is also 0. Now, the first constraint is 1, 1, 1. R1 is 1, R2 is 0, S1 is 0, and the right hand side is 7. The second constraint is x1 is equal to 2, -5, 1, S1 is -1, R1 is 0, and R2 is 1, and the right hand side is equal to 10. Now, can you tell me what we need to do in order to process it forward? What do you see unusual in it? To Yes, we need to add uh, the R1 row to small r, and we need to add the R2 row to the small r row. So here we will get 0, 0. Once we get 0, proceed to the simplex, like just like we do the simplex one. Okay, that is a technique. That is something that you need to know, and you need to perform, like you can actually do the operation. Okay. So now to make the R1 coefficient and R2 coefficient as 0, 0, we need to do the row operation. So the row operation is R row plus R1 row plus R2 row. This is the row operation that we need. So R row is equal to 0, 0, 0, -1, -1, 0, and 0. Now we need to add R1. This is the small r row. Okay. Now we need to add the what we call it, the R1 row. So the R1 row is 1111007. 1111007 and 7, plus the R2 row is 2 minus 510, 2 minus 510, 1 minus 1, and 10. So either you add both these and this, add with this, or you add both these and this, and then adding it with this one. You can do it anyway. So we will first add like these two, and then whatever the sum comes, we will add it to this one to find the new r row. Okay, so the new small r row is equal to, okay, 0 plus 1 is actually 1, 0 plus 1 is 1, 0 plus 1 is also 1, -1 plus 1 is equal to 0. So we got the coefficient of R1 as 0, but we still have a negative. So -1 plus 0 is -1. 0 plus 0 is 0, and 0 plus 7 is 7. Now we will add it to this one, 2, -5, 1, 0, 1, -1, and 10. Now 1 plus 2 is 3. 1 minus 5 is minus 4. 1 plus 1 is 2. 0 plus 0 is 0. Minus 1 plus 1 is 0. So we got both R1 and R2 is equal to 0. And 0 plus minus 1 is minus 1. And 7 plus 10 is 17. So this is the new R row that we got. So we will update it in the table. This is R. This is X1, X2, X3, R1, R2, and S1. The only thing is that you need to consider is that you need to write both these R's, or even if there are 3 R's or 4 R's, you need to write in the in the same sequence, like R1, R2, R3, R4, because you in the end have to eliminate all of these. So just putting a hand on over it and then looking for other variables, it will make it simple. Okay, because we will neglect it in the end. I will show you when I'm done with it. So let's do and this is the right hand side, and now we will write the ratios because it is now ready to be operated like we do the other stuff. And this is the R1 and this is the R2. So R1 will be the same like the previous one. We will not change it. 1 1 0 0 7 0 0 and 7, and R2 will be 2 minus 5 1 0 1 minus 1 and 10. Now this is minimization. Okay, so what we will do in minimization, which one we consider as the entering variable in the minimization? The biggest value but positive. If it were maximization, we will go for minus 4 because it is the maximum negative. But here we will go for the maximum positive. So the maximum positive it is minus 4 actually. It is the minus was in the same black line. So this is 3, this is 2, 0 0 1. Now 3 is greater than 2. So x1 will be the entering variable, the maximum positive. And here now we will find the ratios for it. Now we allocated actually, we identified the pivot column. Now this is the pivot column coefficients 3, 1 and 2. Okay. Now we will find the ratios 7 by 1 and 10 by 2. So 5 is the minimum positive. So R2 will leave the system. You understand? This is the, now here it is the pivot row, and the 2 element is the pivot key element. The pivot key element is equal to 2. So new pivot row, which is equal to the x1 row. X1 will be moving over here. X1 will move from here to here. So it will be equal to 2 minus 5, 1, 0, 1, minus 1, 10, and it will be divided by the pivot key element, which is 2. So 2, it will be 1 minus 2.5, 1 over 2, 0, 1 over 2, minus 1 over 2, and 5. This is the new pivot row. Now, new R row is equal to old R minus pivot column coefficient into new pivot row. It is equal to 3 minus 4, 2, 0, 0, minus 1 and 17 minus the pivot column coefficient is 3. 3 into this new pivot row 1, 2 point, minus 2.5, 1 over 2, 0, 1 over 2, minus 1 over 2 and 5. So here we will get 3 minus 3 into 1, it will become 0. Minus 4 minus 3 into 2.5. So 3 into 2.5 will give us 7.5. So it will be plus 7.5 because minus and minus will become plus. So 3 into 2.5 is 7.5 and minus will become plus. So minus 4 plus 7.5 is 3.5. Now 2 minus 3 by 2. 2 minus 3 by 2, it will become 2 minus 3 by 2. It will become 4 minus 3 by 2. 1 by 2. 0 minus 0 is equal to 0. And 0 minus 3 by 2 will become minus 3 by 2. And minus 1 plus 3 by 2 will become minus 2 plus 3 by 2, which is equal to 1 by 2. And 17 minus 15. 17 minus 3 into 5 is 15. So 17 minus 15 is equal to 2. Now we see that the value of R, the R row value here is 17. Now it has come down to 2. When it come down to 0, we will stop. The first phase will be over when we get the right hand side of the R row is equal to 0. Now it is 2. So it means that we have another iteration to be, to get it done. Now this is the new R row. Now we have only R1 row to be updated. So new R1 row is equal to old R1 row minus pivot column coefficient over here, which is 1, and into new pivot row. So it will become 1, 1, 1, 1, 0, 0, 7 minus 1 into the new pivot row is 1, 2 point, minus 2.5, 1 by 2, 0, 1 by 2, minus 1 by 2, and 5. Last test that. Now, making this row operation, we will get over here is the first will become 0, and we will calculate the all others. So the first will be, which one? 1 minus, it will be the same process, but I just need to, make this 17 equal to 0, and then I will stop. Then there is a tricky part, like transforming from phase 1 to phase 2. You need to have like, it's a bit tricky. I just want to, to know about that thing. That is important. Yes, that is why I want to do this. Yeah, because you need to learn that thing. That is important. important. This is like just like just simplex. Okay. So now we will have 1 minus 1 is equal to 0. Okay. The second one is 1 minus 1 into minus 2.5. So 1 into minus 1 into minus 2.5, it will become 2.5. 1 plus 2.5 is equal to 3.5. Okay. Now 1 minus 1 over 2 is equal to positive 1 over 2. 1 minus 1 into 0, it will become 1. Now 0 minus 1 into 1 over 2, it will become minus 1 over 2. Now 0 minus 1 into minus 1 over 2, it will become plus 1 over 2, and 0 plus 1 over 2, it will become plus 1 over 2. The 7 minus 1 into 5 is 7 minus 5 is equal to 2. So it will give us these values. Now we need to update W according to new rows. Here will be R. It will be R1, and here we will get X1, X1, X2, X3, R1, R2, and S1, and here we will get solution R right hand side, and here we will get ratio. Now the new R that we found out was 0, 3.5, 1 over 2, 0, 0, 3.5, 1 over 2, 0 minus 3 by 2, 1 over 2, 0 minus 3 by 2, 1 over 2, 2. Now we still have positive 2 in the right hand side. So it means that we need to make it 0 and process it for another iterations. And R1 new is equal to 0, 3.5, 1 over 2, 1 minus 1 over 2, 1 over 2, and 2. We'll write R1 over here like we just updated it. And the new pivot was 1 minus 2.5, 1 over 2, 0, 1 over 2 minus 1 over 2, 5. So this is the updated table. Now we see that we still have x3 and x2 as positives. So the maximum positive is x2. So x2 will enter, and this is the pivot column. Now we will do the ratios, and we will find out the leaving variable and the what we call the pivot row. So 2 divided by 3.5 is equal to, and 5 divided by minus 2.5. It will give us negative value, so we will ignore it. Ignore negative, and here we will get something like 0 point something, or let me calculate it. We will get 2 divided by 3.5 is equal to 0.57. So R1 will be leaving the system. You got the point? Now this is the pivot row, and we need to update it. So the new pivot row is equal to old one divided by, and this is the pivot column, which is 3.5. It is equal to 0, 3.5, 1 over 2, 1 minus 1 over 2, 1 by 2, and 2. And it will be divided by 3.5. So we will get over here 0, 1, 1 over 2 divided by 3.5. It will give us 0.142, and it will be given 1 divided by 3.5, 0.28, and minus 1 over 2 divided by 3.5 will be minus 0.142, and 0.142 and 2 divided by 3.5 equal to 0.57. So this is the new pivot row. Yes, you want to add something? Okay. Okay, so now we will update the R row. So the new R row is equal to old minus pivot column coefficient into new pivot row. So the old one is 0, 3.5, 1 over 2, 0, minus 3 by 2, 1 over 2, and 2, minus pivot column coefficient is 3.5, and it will be multiplied by with 0, 1, 2, 0.28, minus 0.142, 0.142, 0.57. We divided it by 3.5. Now here we multiply it by 3.5. So it will give us the same R1 row. Okay. So we can just say that 0, 3.5 minus 3.5 is also 0. And 1 over 2 minus 3.5 into 1 for, let me calculate this one. 1.5 minus 1.5 is equal to 0. And 0 minus 1 is minus 1. Minus 3.2 minus 1.2. Okay. So now we see that we divided this pivot row by 3.5. Okay, so here we get the new pivot row, but for the new z row we have old minus the pivot column coefficient into the new pivot row. So the pivot column coefficient is 3.5 over here, and we divided this by 3.5. So when we multiply it by 3.5, the new one, it will give us the same old pivot row. Okay, so it means that new r row is equal to old minus r1 row. So here 0 minus 0 is 0. 3.5 minus 3.5 is 0. 1 by 2 minus 1 by 2 is 0. 0 minus 1 is minus 1. Minus 3 by 2 minus 1 over 2 is equal to, it will give us minus 1.5 plus, sorry, minus 1, yeah, this is minus 1.5 minus plus zero point 0.5. It will give us minus 1. 1 by 2 minus 1 over 2 is will give us 0. 2 minus 2, it will give us 0. Now here in the right hand side, we got 0. Okay. Now we will update the x1 row. So the new x1 row is equal to old minus pivot column coefficient into new pivot row. Now the old is equal to 1 minus 2.5, 1 over 2, 0, 1 over 2, minus 1 over 2, and 5 minus pivot column coefficient is minus 2.5 into the new pivot row is 0, 1, 0.142, 0.28, minus 0.142, 0.142, and 0.57. Now here we will get 1 minus 2.5 into 0. So it will give us 1 minus 2.5 and plus 2.5 into 1. It will give us 0. 1 over 2 minus into minus 2.5 into 0.142. It will give us, let me calculate it using calculator. So minus 2.5 into 142, I will first calculate this thing. 2.5 multiply by 0.142, it will give us 0.355. Okay, and this will become plus 3.5, and 1 over 2 minus 0.3.5, it will give us 0.14 and 5. Now 0 minus 2.5 into 0.28 multiply by 2.5, it will give us 1.7, 0.7. So 0 minus 0.7 is minus 0.7. Now 1 over 2 minus 2.5 into point. So minus minus will become plus, and plus and minus will become minus. So 2.5 into 0.142. So minus 3.5, and 1 over 2.5 minus 0.355 is equal to 5 minus 6.425. So this is the new x1 row. Now we will update the row. Now the updated W is yeah. This is the exact point where I want to tell you that there are no more iterations because we got 0 in the R row in the right hand side. So that's it. Yes, that's it for no. The point is something else. I will now let you know. Now here, this is the point that I want to tell you. Just you need to ignore these two in this one. Okay. Now, what the original problem that we had? We had maximum z is equal to 2x1 plus 3x2 minus 5x3. We will return to the same. We will return to the same problem, the original one. Okay. Now we will change the constraint here. The constraint will tell you. That is the point that I want to, I wanted to make, clear. Now how we will take the constraints actually. Now here we have x2 and x1. Okay. We will use the right hand side of it as the right hand side of the constraint. Okay. And the value that resides beneath their column, we will take those as the coefficients. For example, here we have x1 is equal to 0. This is not the iteration. This is the we did only 2 iterations, and this is not an iteration actually. This is not iteration. This is just okay. So now we will make the new constraints of it. Those constraints will be changed. Okay, the original one constraints that will be eliminated from the system, that are no longer required. Now here the new constraints are, here we see that x1 is equal to in x2 row, x1 is equal to 0 and x1 is equal to 1. So we will get over here is 1 x1. Now x3 is 0.142, so we will get 1.142 into x3. We will ignore this r1 and r2, and s1 will also be ignored because it is also the surplus variable, and it will be equal to 0.57. Similarly, here we have, this is x2, this is not x1. This is 1x1 plus 0x2 plus 0.145 x3, and it will be equal to 6.425. So these are the new constraints. Now we need to make the table according to this, and then do the one more iteration, and we have the solution. This was the logical part, actually making the new constraint from this table. That was something I wanted to know about it. Not that we get 0. I already told you that when we the right hand, this is for the two phase method. Now here the first phase has ended because we get a 0 in the R row. So when we get the 0 in the R row, then we need to find out that what are the two or three rows, the basic variables. Now against x2, we have here is x1 is equal to 0. So you put x1 is equal to 0 here. You can say that 0x1 plus x2 is equal to 1. So we get a 1x2 plus 0.142 into x3. x3 is equal to 0.57, the right hand side. In the third one, we have x1 is equal to 1, x2 is 0, x3 is 0.145. So 1, 0.145 into x3 is equal to 6.425. Now we make the table. You need to do the iteration yourself, okay? Now we will make it for the z, x1, x2, x3. Yes, yes, yes. This one, yes. It will be -2, -3, +5, and 0. We will equate it to 0. So the 2 will become -2, 3 will become -3, -5 will become +5, and S1 is also already 0 in the, what we say, the, now for the x2 we have 0, 1, 0.142, 0, and it is 0.57. Here we have 1, 0, 0.145. Which one? This one. Now it is maximized. Yes, this is now maximization. So for the maximization, this x2 will be the entering variable, and you can do the procedure and go for the the optimal solution. It will be maximized. This will not the next step. You see now the maximization function, latest maximization function. This one iteration or this one? This one. This one or that one, the upper one? Yes, the last one I made it like equal to 0. So it will be maximized because it is maximization function. So yes, I want to do an iteration. Yes, that is what I want to do. Yes, after it will, they not you don't have to get to 0. It will become maximized. It will give us some value. That will be the final value for it. Because this is maximization function, a maximization function with 0 at the right hand side, how it is optimal? Yeah, it may be like one iteration at most, because we have done the work in the previous phase one, but here we can like do a second iteration or maybe two, but we just transform the question into maximization. Even in simplex, even in simplex, like if you do the simplex problem, so in the start you have to make the solution equal to 0, and then you have to start iteration and making, if it's maximization, it will improve, and if it is minimization, it will go into the minimum or it will remain 0. You have to start it from 0, whether it is maximization or minimization. But that is something. Yes, but that I told was for R. It was not for Z. It is Z. Here it is Z. It is not R. Yes, because this is x2. This is the maximum negative. So this will be the entering variable, and you can see it for when we get all the positives over here, it will end. When we do not get any negative in the Z row, it means that it has ended. The optimal solution has arrived. If it is the maximization, if it is minimization, if all of them, yes, that is the trick of it. In maximization, if you do simplex, you have to make the upper the Z row all positive. If these are all positive, it means the optimal solution has arrived. If there is any one negative in the basic variable, it means that there is an iteration left that you need to do. Only the basic variables. I'm not talking about the slacks or surplus. Only the slack variables. Sorry, the basic variables, x1, x2, or x3, that we need to define. Yes, that is the point that I want to convey. I know, but you were pointing out for the same 0, because I told you that was for R, that was not for Z. And here we have Z. So when we have Z, the situation changes. When we have R, the situation, that is something else. When we have R, we need 0 over here. But when we have Z and we want to maximize, we do not need 0 over here. We will give some, kind of we will iterate it. Yes, I will solve the question for you, and I will make a short video of it, and I can post it. But now I have to go. I have to buy something because in the evening we have my brother's nikah, so I will be also attending it. Plus, I need to do. Yes, I will. I will do it. Yes, I will do the homework. I will complete it. When I come back, I will complete first homework, and then I will do other things. It will take me like 2 hours or maybe like before 12, na? Before 12 in the night, you have to submit it online. So it will may take me like 2 hours or maybe 3 hours, and then I can send it to you. You can write it down and just you have already have like three questions in there. I will send yeah, I will send the other three. Yeah. Yes, yes, yes. Before 3 hours, I will try to send it before. Okay, okay. And one other thing, please. Okay, I will tell you on the messenger. Okay.